In this video, we'll be solving these questions using the equation of motions. Alright, in our previous video, we derived how this equation of motions are gotten. So if you have not watched the previous video, I'm going to leave the link on the comment section so that you don't need to cram. Remember, here we teach from first principle, so you need to understand it. So the question 1 says that a car starts from rest and moves with a uniform acceleration of 2 meters per second squared. What is the distance covered in the third second? So we're going to be starting with question 1. But before you proceed, the 3 basic equations of motions are: the first one, v equals to u plus at. We derived them in the previous video, where v is your final velocity, initial velocity, and acceleration, and this is your time. All right. The second one is s equals to ut plus half at squared. This is your displacement, which is your change in position. This is your initial velocity, and so on. And the third one is v squared is equals to u squared plus 2ax. All right. Now, some persons can include this s equals to u plus v over 2 times t. This is not a new equation, okay? In the derivation, you will find this, because this is just like saying that displacement is velocity times time. But due to the velocity is not constant, okay, so we are going to be using the average velocity, and average is your initial plus your final divided by 2. So that's how this equation came about. So the rest of the equations will always come from these 3. So if you don't understand how this equation came about, please go back and watch the videos. So now let's go back to our equation, to our question rather. So question 1, let's try to list the parameters of what we have. The car is assumed to start from rest. All right, so meaning that the initial velocity is 0. It has an acceleration of 2 meters per second squared. Okay, and then the time is 3 seconds. But look at this question. The question said, what is the distance? Okay, what you're looking for is distance. Now, what is the distance covered in the third seconds? If you analyze it carefully, you understand that this is different from asking you what is the distance after 3 seconds. So let's try to illustrate it. This thing just means, if let's assume this car starts from here and traveled after 1 second, the car is here. This is 1 second. After another second, that's 2, the car is here. After 3 seconds, the car is here. All right. When they are asking you what is the distance covered in the third second, not total distance after 3 seconds. So what we are actually looking for is, we are looking from here to here. That's what we are looking for. Okay, so you need to understand this and know what you are asked to find. Now, to solve it, you can choose any of the equation, the one that best suits you. Me, I prefer to choose this. You can choose any one you like. So you're going to find the distance after 2 seconds, find the distance after 3 seconds, and now find the distance covered in the third second. That is from 2 seconds to 3 seconds. All right. So let's first find the distance after 2 seconds. Using the second equation, that is s is equals to ut plus half at squared. At 2 seconds, you can say s2, that's distance after 2 seconds. Remember, this is 0 because the car starts from rest. All right, plus half, the acceleration is 2 times the time is what? 2. So this is going to give us 4 meters. All right, this is after 2 seconds. Now, what at 3 seconds? That's after 3 seconds. What are we going to have? So after 3 seconds, so S3 Remember, it is from rest. That is why our u is 3. Okay. So this is equals to 9 meters. All right. Now, what is the distance covered in the 10 seconds? So from this our diagram, it means that from here to here is 4 meters. Whereas the total distance after 3 seconds is 9 meters. So what is from here to here? We are going to have distance covered in the 10 seconds, in the third second is 9 meters minus 4 meters. So that will give us 5 meters. You might be wondering, why are we using distance, whereas we defined this to be displacement? I explained it in the previous video, so make sure you go and watch it. This car is traveling in a straight line and there's no change in direction. So once the movement is in a straight line and there's no change in direction, our distance is equal to our displacement. Okay? So let's move to the second question. The question said that a motorcycle is traveling at this. From the unit, this is velocity. You should be aware. Velocity is in meter per second. Acceleration is meter per second squared. It suddenly brakes uniformly and comes to a stop in 5 seconds. Find the acceleration and the distance it traveled before stopping. So let's first write our parameters. So from the question, the initial velocity u is equals to 20 meters per second. That is the velocity it was traveling with. Final velocity v is equals to what? 0 meter per second. Why? It stops. The vehicle has stopped, so there is no longer velocity. And the time given is 5 seconds. Alright? So we are asked to find what? To find the acceleration and which other thing are we asked to find? Distance. Alright? So which of the equations for most are we going to use? Let's use the first one, which is v equals to u plus at. So using this to find our acceleration, v is what? 0, it has stopped. What is your initial velocity? 20. Plus, we are looking for a, that's 5a, because your t is 5. Alright? So if you can, from here, you can do some of the formula. You can minus 20 is equals to 5a, so that your a is equals to minus 20 over 5, which is equals to minus 4 meters per second square. So this is negative acceleration. You call it what? Deceleration. It means the thing started slowing down. Alright, so we have found our a. To find the distance traveled, we are going to use s equals to ut plus half at squared. So that our x, what is our u? Here your u is no longer 0, your u is 20 meters per second because it started with an acceleration. So you're going to be having 20 times 5 plus half negative of 4, 5 squared. Alright, so this is going to be giving you 100 minus 50. So distance traveled is 50 meters. Okay, so with this, it is very easy to solve questions on equations of motion. If you have not subscribed, please do not forget to subscribe to the channel, like, share, and comment. See you in the next video.